All right, so this video is about volume formulas and area of a sector. All right, so first thing is, these are all the shapes that we're going to find the volume of in this class. Also, we might talk about surface area too. It's pretty easy. It just means the area of the surface. But a volume refers to how much space is inside and how we measure that space that we have. And so we can measure it in cubic units. All right, the first shape is a cylinder. This is a cube. This is a right triangular prism. This is a cone, a pyramid, and a sphere. The volume formula for these first three are all basically the same. It's basically the volume is equal to area of the base times height. All right, so it's generally written V equals capital B times lowercase h. And capital B represents area of the base. All right, so whatever the area is, you take that area and multiply by its height. The reason why all these have the same formula is because it's all some base and is uniform all the way up to that next side, which is also the base. So if you think about a cylinder, a cube, this right triangular prism, you got some triangular base and there's a uniform distribution all the way to the top. So it's a simple formula for finding the area of it. So, the volume of it. You simply find the area of the base, bottom side, top side, doesn't really matter. And then multiply by the height. This would be the height. All right, with a square, pretty much the same thing. Area of the base, which is side times the height. So the square is all, and the cube is all the same. Whatever the height is also S, because all the sides are equal. So it's basically, for a volume for a cube, it's basically side to the third power, but it still fits the same description. Side times the height, which is also the side, same length as the side. And the cylinder, the volume form for it, the general form is area base times height. To be more specific though, it is, the base is a circle, so its area is pi times radius squared times the height. And the height would be like the height of a Coke can, all right? So sometimes people give you a cylinder that's laying sideways and you want to know the height. If you want to know the height, it's not if they gave you a cylinder to look like this, all right? So the height wouldn't be top to bottom. It would still be the section that connects the two bases. All right, so anyway, there's pi radius squared times height. All right, so the area of the base is pi radius squared times height of it. These other three, the cone, the pyramid, and the sphere, they're slightly different because here the distribution isn't uniform from top to bottom. This is still your height there, that perpendicular segment, but because the distribution isn't uniform, we can't use this formula. So the volume for this one is 1/3 area of the base times height. So 1/3 times area of the base times height. Basically is a circle, so essentially 1/3 pi radius squared times height. All right, so anyway, this is a general formula for it. This is a more specific formula for it. This is a pyramid. Volume is still 1/3 area of the base times the height. Now this pyramid has a square bottom. Some may have different shapes for the bottom. All right. So anyway, so this square would be side times the height, and the height would need to be an altitude here. You got another height in both of these shapes. It's called a slant height. This side here, that's slanted, is not a true height, but we call it a slant height. Same with this pyramid. This right here would be our slant height. All right, really can't write it in that space, but slant height is what it says. But anyway, so we have special needs for it, properties for it. For one is like, it would be like a hypotenuse inside this right triangle I formed there. In the same case here, it could be like the hypotenuse within a right triangle being formed in that picture. So it does have some things that we can use for it, but it's not the true height. So when we're talking about the true height, we're talking about the perpendicular segment from top to bottom. All right, so those are, oh, and the last one is spear. Volume formula for spear is different from all of those. The volume formula for spear is 4/3 area of the circle times, well, actually 4/3 pi radius to the third. And that's it. There's no more times on the end there. So that's just it for the volume for a spear. In just a minute, I'm going to tell you how to draw these, because you kind of need to know how to draw these, because you can draw them all the time. So I'm going to tell you how to draw each one of these shapes now. So I'll pause the video and copy the handy formulas you didn't already know in some organized fashion. And I know there's a lot going on the board, but you write it down in some organized fashion would be nice. Also, after you unpause it, I'm going to teach you how to draw each one of these shapes really quickly. All right. All right, the first thing is cylinder. Essentially, draw a circle. Then you connect that circle on the edges to another circle. Pretty easy, and that's a cylinder. Now, after you draw it, in geometry, we like to show the piece that's behind that we can't really see with a checkered line. So after you draw it, I go back and I erase a small piece in the back there to show that that's behind and everything solid can be seen because it's not behind the figure. That's in the back of the figure. All right, so it's a cylinder. All right, drawing the next one was the rectangular prism. So let's look at this one, the rectangular prism, triangular prism. All right, so you're drawing it, you start off with a triangular base. And basically what you want to do is you want to draw 3 more lines. But you want to draw the lines in such a way that when you draw the other lines, this should be parallel to this one. So the side above is going to be parallel to that side. So this is why I didn't make it go all the way to the top. I knew it was going to be parallel coming downward. It's going to connect there. My next side is going to be parallel to this side. So I'm going to make this side look like it's parallel to it. And then the back side is going to be parallel to this back side. So it's going to make it horizontal, so it's parallel to it. So that's it. Now, I would think about, okay, what's in the back? Well, this would be in the back. I really couldn't see that. If that was like a block of cheese or whatever, that piece would be invisible to me. All right, the next one was a cube. So it's pretty easy. All right, so just like draw a cube. Start off with a square or a rectangle, and then you're going to draw another square or rectangle off a little bit to the side from it. All right, ideally you want to make them the same size. I'll try to. Then connect the corners. This corner corresponds to this corner. This corner corresponds, that one corresponds there. All right, this side corresponds here, and they ought to look parallel here, these two opposite sides. And then the last one is this one. All right, should be parallel to the other side. Now that's in the back, so are these sides. All right, so that way anyone looking at it could tell, oh, this is the front of it, and that's in the back. And if it's a solid figure, I couldn't see that piece. All right, the other picture was of a cone. So start with a circle and connect at an angle. And there you have it. You got a cone. Usually you might put a radius in there someplace. And don't forget to checker the little pieces in the back that wouldn't be visible in a solid figure. All right, the next figure was a spear. So you start off with a circle, like any other circle. Then to show it's 3-dimensional, you draw like a little slice of a circle here, and then give it this other side back here. Kind of like an oval. But I would generally put a radius in there too. Anyone can see, okay, that's definitely a spear. And the last one was a pyramid. So generally pyramids have square bases. And then afterwards you want to make the sides connect at one point. And you're going to make pieces that you couldn't actually see invisible by making them checkered. All right, so that's a pretty decent pyramid. All right, so I think that was all the shapes. Make sure that's it. All right, so those are all the shapes. All right, and another formula I got to mention to you guys is area of a sector. So after you get all those notes down, get this, area of a sector. sector. Basically, if you have a circle, assume this is a circle, say circle C, and I wanted to find this little shaded region here. All right, in order to find that, I would need to know what this angle is. And let's say that angle is 70 degrees, right? All right, so you want to find the area of that sector. Basically, the formula is area of a sector. All right, so it is the angle over 360 times pi radius squared. So my angle is 70. It would be 70 over 360 times pi, and I need to know my radius. So let's say I gave you a radius and say this radius was 10. All right, so it would be 70 over 360 times pi times 10 squared, which is 70 over 360 times 100 pi, which is, it's about 61 square units. And keep in mind, that 10 wasn't there at first. I just didn't write the problem completely. Now it's there, and that's why we knew that radius was 10. All right, so the next thing is about arc length. And basically, arc length is you're looking for a part of the circumference of a circle. So it's referring to how long is an arc in the circle. For example, it says find the length of arc MT in circle P. So here's circle P. Arc MT is this minor arc, which is right here. And then once you find the length of it, all right, well, that length is a part of the whole circumference. So the formula for arc length is equal to angle over 360, so that part over the whole, times the circumference formula, which is 2 pi r. So because we're looking for a portion of circumference, the proportion of it is whatever the angle is out of 360 times the whole circumference formula. So if I want to find the arc length in this circle, MT, the formula says I should have 110 degrees over 360 degrees times 2 times pi times the radius. In this case, the radius is 7. I can really plug all that into the calculator. So that's going to be equal to about 13.4 square units. All right, so that's how you find the arc length. Is that portion of this over the time circumference. All right, one last note. No, actually, that's it. All right, so that's all I have. Good luck.